This time, we are asked to evaluate the Laplace transform of the function 3t minus 10. Now, we can use here the linearity property because we already have the rule for the Laplace transform of a linear function t and a constant function, in this case, minus 10. If we're going to apply here the linearity property, okay, this would be equivalent to, okay, the Laplace transform of simply 3t plus the Laplace of our negative 10. Okay, this is the idea for the linearity property. We can break them as long as they are actually separated by addition. We know this can be written as actually Laplace transform of 3t plus negative 10. So we're using the addition so that we can actually just use linearity property. And this time, after this is also equivalent to taking out some certain factors of constants. In this case, a scalar. You have here Laplace transform of just simply t. Plus here, you can even take out negative 10. And you will have here the Laplace transform. Okay? Or you can have this, something like this as well, of positive 1. Why are we doing this? The reason for that is we already have the rule for this and for a constant which is just equal to 1. So simply substitute that there and later on multiply with the scalars to get your final form. But of course, if you would like to really follow the procedure of determining Laplace transform, you can of course look into the long method of getting the Laplace transform of any function of t be equal to the integral of e to the power of negative st, your function of t dt, as it's being integrated from 0 to infinity. Your function here would be the entire form to be substituted here, and of course you are tasked to apply methods for able to separate the integrals and later on get the result. I'll be leaving that to you because then again, we already have the rule for the Laplace transform or any linear function is simply t. It's actually equivalent to 1 over s squared. And for 1, okay, it's actually equivalent to 1 over s. So basically, you can actually apply it here. That's a 3 times Laplace transform of t, which is just 1 over s squared, plus you have, or you can use now minus 10 times the Laplace transform of 1, which is 1 over s. This is equivalent to 3 over s squared minus 10 over s. This is the Laplace transform of the given function 3t minus 10. Now, I wasn't able to emphasize this in the previous videos, but there are also some additional concerns you can add here as long as your s must be greater than 0 so that this will not be equivalent to 0. And of course, we know that our function of t must be true for t greater than or equal to 0. This is just one of the statements that you can add. But of course, if you simply ask about the value of your Laplace transform, you can remove this and simply stick with this result here. This is the result for this item. Again, I'll be leaving the proof of showing the entire result where this is also equivalent to the use of this when our f of t is the entire function 3t minus 10. Thank you very much for watching.